Computer programs manage information, and in all likelihood that's why you're developing an application in the first place. This information could be personal information, such as managing a soccer schedule, or it could be a simple program to balance your checkbook. The information you're managing could be quite complex and related to a business. Maybe you're writing an order entry system, or maybe you're writing a game, and the information you need to manage is where on the screen the users move the mouse. So you need to manage information and store information. One way to store information is in variables. Another way, of course, could be in a database. We're talking about variables here. So variables are one place that you'll store information. Variables are in memory, so they're not on the hard drive. Now you can, if you need to, copy the contents of a variable and write it to a file, and then later on you could read that file and put the information back into variables, but while your application's running, the variables exist only in memory. You can create variables at the start of your programs, or as needed later on. Variables have three components. The data type, which is the type of information you're storing. Is it a number, a string, a date? Variables need a name so that you and the compiler can distinguish one from another. And then variables have a value, which of course is the information stored in the variable. There are some rules for variable names. A variable name has to begin with an alphabetic character or an underscore, and then contain only alphabetic characters, numbers, and underscores. And if you begin with an underscore, there has to be at least one alphabetic character or number in there. And then your variable names have to be less than 1023 characters, which should not be too imposing a limit on you. Your variable names should be descriptive and they should be of reasonable length. So imagine you see code such as A equals B plus 7. This tells you nothing. Unless it's a very, very small program, you don't know what variable A represents, and you don't know what variable B represents. Although those names are of reasonable length, they're not very descriptive. And if you go back to the program 3 months later, you're not going to know what that line of code is doing. Consider another line of code that says the salary that the employee gets after receiving a raise equals the salary that the employee is making now before the raise happens times 1.05. Well, those variable names are pretty descriptive, but they're awfully long. So maybe what you would do instead is have a line of code that reads new salary equals current salary times 1.05. And that tells you everything you need to know. You take the current salary, you multiply it by 1.05, which is a 5% raise, and you store that to a variable called new salary. So keep your variable names short, not too short, make them descriptive, and that way your code is easier to type and easier to read. To declare a variable and have the runtime allocate space for it in memory, you first specify the data type you want to use, and then the variable name. So for example, in the first line of code, we're declaring a variable called counter1 and specifying that it should be an integer. In the second line, we declare counter2 also as an integer and assign it a value of 612. In the third line of code, we're declaring three variables, message1, message2, and message3. Message2 then is assigned a value of an empty string, and message3 is assigned a value of hello. Now we didn't assign values to counter1 and message1, and that's okay, this code will compile and run. But you can't use counter1 or message1 in your code until you assign them values. So you can declare the variable anytime you want, but if you actually want to use the variable, whether you're adding to it or printing it, then you have to give it a value. Variables have a lifetime and a scope. The lifetime of a variable represents the length of time that the variable is available to you to use in your code. If you declare a variable in a method, that variable will be in memory while the method is running. When the method's done running, the variable is no longer in memory. The scope of a variable determines what code can use it. So a variable declared in a method will be available only to that method. You can think of the variable as belonging to the method. It's not available to other methods. To have a variable be available to multiple methods, then you declare it at the class level. A variable declared at the class level is available to all of the methods in that class. Let's go see a demo of creating and using variables. I'm at the sample application, Data Types and Variables. Let's take a quick tour of the Visual Studio IDE as a refresher. In the upper right is the Solution Explorer, and that contains my project and my code files. The bottom window is the Properties window, where I can set properties of items in the project. I can set properties of the project itself. I can set properties of controls on a Windows form or controls in a web form, etc. We're using a console application here, so there's not much need for property setting. The middle window is the code editor. That's where I write my code. The bottom window shows me output, which will show me the results of building the application. And I can also check to see if there are errors and see what errors there are in my code by looking at the error list. When I run the application, the code in the main method runs first, and that code will display the main menu for the application and let me choose which example I want to run. I also have breakpoints set in each of the examples, and a breakpoint will temporarily pause execution of the program, and then I can step through the program one line of code or more at a time, and that gives me a good opportunity to check the values of variables and make sure that my code is doing what I hope it's doing. So let's look at some examples of variables. This first method, called variable lifetime, declares a variable called total amount, specifies that it's an integer, and assigns it a value of 100. The next line of code adds 100 to that variable, and so total amount will now be equal to 200. The variable total amount is declared inside this method, and so by default is not available in other methods in the class. If I want it to be available to other methods in the class, such as the variable scope method, then I'll have to declare it outside of the methods and at the class level. So this line of code here does that. Declares the variable at the class level, and therefore I can use that variable inside the second method, variable scope. Now if I comment this line of code out, and I have not declared the variable at the class level, and I try to use it in another procedure, watch what happens when I build. I get an error. The total amount variable does not exist in this method because it was defined in a different method. So now I'll uncomment this, and now I can use that variable in multiple methods. Okay, let's run this application. I can click the green arrow or press F5, and that will start the application. This brings up the console window with the main menu. Now let's run that variable scope method. I'll press A. The breakpoint pauses execution, and the total amount variable already exists because I defined it above. And it has a default value of 0. I haven't assigned it a value yet. I'll do that in this line of code. I'll step over that line of code, which runs that single line of code. Total amount is now equal to 100. Then I'm going to step into the show total amount method, which uses the writeLine method of the console class to write a string to the console window and display the value of total amount, which is 100. I'll step over that. Switch over to the console window, step over again to actually run that line of code. Now step over to the console window, total amount is 100. So what you've seen in this example is declaring a variable both inside a method and at the class level, And then we looked at variable lifetime and variable scope. Variables have three components. They have a name, they have values, and they have data types. In fact, all information has a type, and the type defines how the information will be stored, how you'll use the information, how you can manipulate information, and how you can display it. So depending on the type you declare a variable, that determines a lot of the ways on how you will use that variable. The .NET framework contains structures and classes that represent all of the various types of data, whether it's numeric data, or string data, or date or time data. It's all defined in the .NET framework. And then all of the data types in both Visual Basic and C# are based on a .NET framework structure or class. And this winds up being one of the benefits of the .NET framework, is that data types are constant and the same across languages. In the old days, a data type in Visual Basic wasn't the same as a data type in C++, for example, and so it was hard to share data across multiple languages. In the .NET framework, that limitation goes away. A string in Visual Basic is the same as a string in C#. Same thing with an integer or a decimal or any of the other data types. And that's because they're based on data types in the .NET framework, which underlies both Visual Basic and C#. Let's look at the integer data types, and there are a number of them. We'll start with the smallest and go up to the largest. The sbyte data type is based on system.sbyte in the .NET framework, and this stores a signed 8-bit integer between -128 and 127. Signed means it holds both negative numbers and positive numbers. The byte data type is based on system.byte in the framework, and that holds numbers between 0 and 255. The next largest integer data type is short, based on system.int16. This holds a 16-bit integer between -32,768 and +32,767. There's an unsigned version of this, which stores numbers between 0 and 65,535. Increasing in size, next we come to the int, based on system.int32. This is a 32-bit integer between -2 billion and +2 billion. The unsigned version is uint, and that stores numbers between 0 and 4 billion. And the largest integer data type is the long, based on system.int64. This is a 64-bit integer between negative a very large number and the positive very large number. And then there's the unsigned long, which stores an unsigned integer between 0 and a very, very large number. So how do you choose an integer data type? There's a lot of choices there. Which one do you use? Well, the first thing you want to do is choose the data type that's appropriate for the type of information you're going to be storing. If you need to store numbers between 0 and 100, there's no reason to use a long data type. That's going to take up much more memory and is capable of holding numbers that are dramatically larger than you'll ever need to use. On the other hand, choosing the short, which only goes to 32,767, is going to cause you problems the second you need to store 32,768. So you want to choose a data type that can handle the information you're going to be storing and give you enough room to grow your application. Because you certainly don't want to have to go back and change the data type later on when it turns out you're storing numbers that are larger than what you thought. On the other hand, you want to balance memory requirements and performance. The int data type requires twice as much storage space as the short. But on the other hand, int and long are more efficient because the .NET framework represents numbers as either 32-bit or 64-bit values. So in general, you should use the int data type unless you have concerns about memory usage. If you're storing 10, 100, 1,000 numbers, go ahead and use integer even though it requires more storage space than short. On the other hand, if you're doing complex calculations and you're managing 1,000,000 numbers, then you might want to go with short instead of integer, because saving 2 bytes 1,000,000 times adds up. Data types are based on structures in the .NET framework, and a structure is a type of class. And because the data types are based on structures, they have fields and methods that you can use in your code. For example, data types will provide a min value and max value field, and that represents the low end and the high end of the range of values. So you could use min value and max value to determine the smallest and largest integer that can be stored in a particular integer data type. In addition, you can use the toString method, which will return a string representation of a value. And you can then specify how you want the string to be displayed. So for example, you could specify that you want an integer displayed with commas separating the thousands. Now this isn't limited to integer data types. In fact, most of the data types that you'll be using have min value, max value, and toString. The integer data types store whole numbers, so you can't use decimal places. If you need decimal places, then you'll use floating point data types, and there are 2 of them. The first is float, which is based on system.single in the .NET framework, and that holds a 32-bit single precision floating point number, and you can see the range of values it stores here. Pretty large numbers. Even bigger than float is double, which is based on system.double, and that's a 64-bit double precision floating point number, and that holds a larger range of values than float. In general, you should use double unless you have valid concerns about memory usage. Double does take up twice as much storage space as float, but it's more efficient, and also it's more accurate. So if you're doing complex calculations down to lots of decimal places, that's another reason you'll want to use double. The decimal data type is based on system.decimal in the .NET framework, and it holds a 128-bit number, and you can see the range of values that it holds. So it holds smaller numbers than the floating point, system.single and system.double, but it holds them with greater precision. So you'd use the decimal data type if you're working with money. If you're doing financial calculations and you want the utmost in precision, you'll use the decimal data type. You saw earlier that all data types provide the min value, max value, and toString fields and methods. The decimal data type has some additional ones. Truncate will return the integer part and discard the fractions. Round rounds to the nearest integer, or you can also specify the number of decimal places to round to. Floor rounds to an integer smaller than or equal to the current value, and ceiling rounds to an integer greater than or equal to the current value. And let's go take a look at working with floating point and decimal data types. I'm running the sample application. Let's take a look at some of the fields and methods that are available to data types. So I'll press B, and we'll look at minimum and maximum values. I've set a breakpoint in this method to pause execution. And this code is going to display the minimum value and maximum value for each of the data types. So to find the minimum value of a byte data type, for example, I can say byte.minValue. And if I say byte.maxValue, that will display the maximum value. And that's true for each of the data types. Integer, long, and I've included here some data types that we'll look at shortly, such as date-time, which also has a min value and a max value. So I'll continue execution, and the console window displays for each of the data types the smallest number and the largest number that it can hold. Let's look at converting to strings. You'll often want to display the values of variables, and so you'll be using the toString method of the various data types quite often. Let's take a look at that. I'll press C, and we'll move into this method here, formatting with toString. declare a variable called total amount as an integer and set it equal to 1,000. And we'll step over this. So now total amount has 1,000 stored to it. And the first thing we're going to do is call the toString method on that variable and display 1,000 as a string. Nothing too exciting yet. I can pass to the toString method a format string that specifies how I want the variable displayed. If I pass a G, that says I want the variable displayed using the general format, D is the decimal format, N is the number format, C is the currency format, and X is the hexadecimal format. So if I now run this code, I can see that 1,000 displayed in the general format is 1,000. Also displayed in the decimal format is 1,000 because there aren't any decimals. When I display it in the number format, then I automatically get commas separating the thousands and 2 decimal places. And that, of course, is going to be based on how the machine's set up. So in countries where periods are used to separate the thousands, then this would show up that way, of course. The currency format adds a $sign to the front and then displays this as dollars. And there's the hexadecimal format used to display the variable 1,000. Let's take a look at working with decimal data types next. I'll press D, and we'll look at the decimal literals example. And here I'm declaring a variable total amount as decimal, and then I set it equal to 45.61 M. Now why do I do 45.61 M? Let's see. If I create a variable, if I type this, total amount equals 45.61, now the compiler has to think about this for a second. I've declared the variable total amount as decimal, but I typed 45.61. Now 45.61 is not a decimal. It's numbers that I typed into the code editor. So the compiler is going to have to determine what 45.61 is. It could be a float, could be a double, it could be a decimal. All 3 of those data types can hold 45.61. So the compiler has to choose one. And by default, it's going to choose double. Now watch what happens if I try and build this. Let me stop it first. And now I'll try and build this project, and it won't build. 45.61 being a double cannot be implicitly converted to a decimal. In other words, the compiler's not going to do this conversion for me. And the reason it won't is because the double holds larger numbers than the decimal, and the compiler is not going to take the risk of throwing data out for me. So what I need to do is explicitly declare this to be a double by typing M. And now when I build this, it builds just fine. So let's remove this line of code and run the solution again. I'll press E, and we'll go into the decimal data type method. And here I'm declaring a variable total amount as a decimal, and again setting it to the same value as before, 45.61. Then I'm going to create variables called total dollars and total cents. Now we have a restaurant bill where we went out to dinner, and the bill arrives, and we're going to play dollars and cents. And the way you play dollars and cents is that one of the members in the party pays the dollars and the other pays the cents. So we need to figure out what the dollars and cents are in the restaurant bill. The total amount is 45.61. Decimal.truncate will return the integer part of the number, which in this case would be 45, and the cents is the total amount minus the total dollars. So let's step through this. Step over, total amount, 45.61. When I truncate that, the dollars is 45. The remainder is the cents. And now we can see that the bill was $45.61. You're going to pay the $45. I'll pay the 61 cents. Now let's set the total amount to another number with even more decimal places. There's total amount set to that number. We'll display that amount. It's 45 dot, and all of the decimal places are in there. Now let's round it. So if I pass total amount to the round method of the decimal data type, it rounds that to the nearest integer, rounded to 0 decimal places by default. I can also specify the number of decimal places I want this rounded to. I want to round it to 4 decimal places, and that's 45.6746. So round with no additional argument rounds to 0 decimal places, or I can specify the number to use. Now I'm going to set total amount to a negative number and display that. So profit last month, negative 45.61. I'm going to create 2 additional decimal variables. Total $1, total $2, and I'll set total $1 to decimal dot floor of that negative number, and total $2 to decimal dot ceiling of that negative number. Floor rounds down. So negative 45.61 rounds to negative 46. Ceiling rounds up. So that will take negative 45.61 and round it to negative 45. So let me run that line. So rounding down, we used floor, and that rounds to the next integer closest to negative infinity. We used ceiling to round up, which rounds to the next integer closest to positive infinity. Okay, I'll continue running this. So in this demo, you've seen how you can use some of the fields and methods of the various data types. We've looked at numeric data types. Let's move on now and look at character and string and the other data types. The char data type is based on system.char, and it represents characters. It literally holds a 16-bit numeric value between 0 and 65,535. And each one of those numbers represents a Unicode character. So the number is a code point, and that code point represents a character. Now there's 65,000 plus characters. You're pretty familiar with the first 128 of these. That's the ASCII character set. So you can use the char data type to store individual characters. For example, a key that the user presses on the keyboard. The char data type has 2 methods. Convert from UTF-32 returns the character associated with the code point, and convert to UTF-32 returns the code point associated with a character. So you can convert from the numbers to the characters and back again. The char data type also has methods to determine the category that the character is in. For example, is it a control, a tab, carriage return, line feed? Is it a digit, a letter or a digit? Is it lowercase? Is it a number? Is it punctuation? Is it a separator, such as a space? Is it a symbol, a plus sign, a minus sign, for example? Is it uppercase? Is it white space? You can use these methods to determine what type of character you're working with. The character data type holds a single character. The string data type is based on system.string and holds a series of characters, anywhere from none of them to 2 billion characters. That gives you the ability to store a lot of text in your string variables. If you want to include quotation marks or backslashes in your strings, then you want to use either an escape sequence or put an @ sign in front of the string. So in both of these examples, we want the string to include a quotation mark. The first example, greeting1, uses the backslash to tell the compiler that the quote is supposed to be in the string. So that's used in front of the word Robert and after the word Robert. In the second example, the @ sign is instructing the compiler that the two double quotes in front of Robert are actually supposed to be a quote in the string, and the second set of double quotes after Robert is also part of the string. Otherwise, the compiler would think that you had two strings here, hello as one string, and then Robert starting the second string. So the @ sign gives instructions to the compiler that you meant to type two quotation marks and you want one of them in the string. The bool data type is based on system.boolean, and it has two values, 0 which is true or 1 which is false. And you use the bool data type to test conditions. So in this code, if the value of first variable is greater than the value of second variable, then write that using console.writeLine. First variable greater than second variable is an expression, and that will evaluate to true if the first value is greater than the second value, and it will evaluate to false otherwise. And in the if statement, the expression is surrounded by parentheses. The last data type we'll look at is object. The object data type is based on system.object, and in the .NET framework, everything ultimately derives from system.object. It's the highest level object there is in the entire .NET framework. The object can contain any data type, whether it's integers or decimals or floating point or text, doesn't matter. You can store anything you want in an object data type, including another object. The object data type provides the getType method to determine what type of data you're storing in there. And it's important to understand that, in fact, you don't actually store the value of the variable in an object data type. What you're storing is a pointer to the location in memory where the value is held. And this means when you use an object data type, there's some overhead involved because the runtime has to go look up the value in memory and bring it back down to the data type. If you change the data type, the runtime has to then go and write that into a different location in memory. So there is some overhead involved in using object data types. Let's go see a demo and see how to use this last group of data types. I've got the sample application running. Let's go look at the car, string, boolean, and object data types. We'll start with car first. I'll press F, and we're in the car data type method. And the first thing we're going to do is convert from a code point to the actual character. So this code uses the convertFromUTF-32 method on the car data type to return the character associated with code point 82, which is R, and then uses the convertToUTF-32 method to return the code point associated with that R, which is 82. So you can use these two methods to convert from a number to the actual character. Next, we'll define three character variables. Car variable 1 is the character A, car variable 2 is the character 7, car variable 3 is the character plus. Notice that I'm using single quotes to denote these as characters. You use a double quote to denote a string. Now I want to know what category these characters are in. So I'll use the various is methods on the car data type. First we'll see if the letter A is a control character. This should return false, and it does. Is A a digit? That should be false. Is A a letter? That should be true. And it is. Is a capital A lower? That should be false. Next, we'll look at car variable 2, which is a 7. Is this a number? That should be true. Is it punctuation? And the answer to that should be no. And then finally, we'll look at char variable 3, which is a plus sign. Is that a separator? The answer is no. Is it a symbol? This should return true. And finally, is it white space, which should return false? So char works with an individual character. String works with a string of characters. Let's look at the string data type. I'll create two string variables, greeting1 and greeting2, and I both want them to contain hello, Robert, and Robert to be in quotes. And there are two ways I can do this. One is I can use the backslash. The second way is to use the @ sign. So I'll step over these two, and then display greeting1 and greeting2, and it displays Robert in quotes. Now what happens if I don't do that? So let's say I left out the backslash, and in fact, to do this, I want to stop execution for a moment. I type, hello, Robert, in quotes. Now the compiler is confused because the compiler thinks that this is a string, and it has no idea what Robert with double quotes is. So what I need to do is tell the compiler that this quote belongs here, and in fact this quote does too. Now I've told the compiler this is the string, and Robert is surrounded by a quote. The other thing I can do is use the @ sign, and again, if I leave that out, I'm once again confusing the compiler. The compiler now thinks that this is the string, and I've set greeting2 equal to hello, and then it sees the rest of this and doesn't know what that means. So if I put the @ sign in front of this, then I've informed the compiler that these two quotes are a single quote in front of Robert, and these two are a quote after, and this quote and that quote denote the string. Okay, let's run this again. Let me exit out of this for a second. I forgot to put my breakpoint back. There we go. Now I'll run this. And we'll go back in. There's displaying hello Robert in quotes. Let's look at backslashes. I want to display the following. The file is on, double backslash the name of a server, backslash the name of a directory. So the file is on the server named server in a directory called all code, and I want to display that. So I use double backslash and a single backslash, and let's see what I get. I get not exactly what I wanted. What happens here is the compiler sees this, and it says the first backslash tells me that the next character should be in there, so it displays the single character. The compiler looks at backslash A, which is a control A, which actually beeps. So this line of code says the file is on single backslash server, then beep, LLCODE, period. That's what I get. So what I really want is to display two backslashes before server and one after. So this code here does what I want. Double backslash server, backslash all code. The first two backslashes get interpreted as a single backslash. The next two get interpreted as another backslash, and these two get interpreted as a backslash. Now maybe what's easier is to just use the @ sign in front, which says that the contents of the string are a literal. Don't interpret these as control characters, just print what's in there. And finally, this is a little bit easier way of getting the same thing. So the @ sign says the string is literally the string. You can also use the escape characters on individual characters. Okay, let's look at the Boolean data type. I create a variable called first variable and store 7 in it, and second variable contains a 6. If the contents of the first variable are greater than the contents of the second variable, then run this following line of code. First variable greater than second variable is an expression, and that expression will evaluate to true or false. And in this case, it evaluates to true. In an if statement, I need to enclose the expression in parentheses. The runtime will then evaluate that, and because 7 is greater than 6, that gets displayed. And finally, we'll look at the object data type. I declare a variable called anything as object, and I can store anything in it. So first, let's store 7, which is an integer, in there. And then we'll display the value of anything, and also use the getType method of the object data type to determine what type of value I've stored. And that returns system.int32. It doesn't return int, which is the C# data type. It returns the underlying .NET Framework structure, system.int32. Next, we'll store a double in there, 65.76. And finally, a string containing the letter A. So you can store anything you want in an object, as you see in this code, but understand that that's inefficient. Because when the runtime runs this line of code here and assigns the 7 to anything, it stores the 7 in memory and then stores in the anything variable a pointer to where the 7 is stored in memory. And then on this line of code, the runtime needs to go fetch the value of anything. Anything contains a reference to where that value is, so the runtime gets the reference and then goes into memory to get the value. So anytime you assign a value to an object or read the value from an object, there's an extra step there because the object variable only stores a pointer to where the actual value resides. So the object type is handy in that it can store anything, but it is quite inefficient. So in this demo, you've seen the car, the string, the bool, and the object data types, and you've now seen examples of all of the data types available to you in C#.